These data are merged from a set of ION files into a single experiment frame, and each VAMAS block represents a different ION file that was in a directory. Now the time to mass calibration has been calculated from the ION file, but we observe that when we overlay two of these data sets and then convert them and then overlay them as an individual mass, you can see that the mass calibration was not consistently done for these data. So what I'm going to do now is redo the mass calibration. I believe that this one is the one that has the incorrect mass calibration, but if we're going to look at these data, having a consistent mass calibration is important, and one way to get a consistent mass calibration is to perform the calibration in CASA. So we'll do this by using regions, and the regions will be used to identify peaks, and these will associate a mass with a given time channel. We'll also use the exact mass calculator, and I've got in a file that I had prepared earlier, so I can load, and these include a range of different masses that I might use for my calibration. So the problem is to associate a peak with its mass and time bin. So the first one we'll do is we'll pick a relatively high mass peak, and we're looking at 55. So there's a peak that could be used to calibrate, assuming that this is the C4H7. So let's choose this one, and what we're going to do is we've got the quantification parameters window up, and we can then say create when we select a line, and what this has done is created a region. We need a region that will span all of these peaks. What will happen is the formula will be calculated and the exact mass will be determined from this formula, and the peak maximum will determine the data channel, and therefore there's a relationship between a data channel and a mass, and that will be used in a least squares fit to produce the relationship between the mass and time. So what we need is at least 2, but we will put 3 in this case, and we will go for another one which will be somewhere lower down. So let's go for this region here, and on the exact mass calculator we'll untick the create so we can interrogate these. So that's a peak which is C3H6, or we could try C3H7. Let's have a look at that one. Okay, let's try this one. So let's create, and again we need to define the limits so that it encompasses all the peaks that need, for which the peak maximum must be determined. And then one more. Let's go for this one here. So we've got the CH3. So having defined these regions, we'll now propagate the regions to all of these spectra. And if we overlay these spectra, so overlaying these spectra in the active tile allows us to use some of these operations on this toolbar. So calibrate ToF spectra. Each one has 3 regions on it, so when I press the calibrate, a dialog window comes up and offers us 2 possible calibration options. One is using 2 parameters in a least squares fit, the other is 3 parameters for a quadratic, and the preferred one would be the 2 parameters. This is a much stiffer model and is more likely to give a consistent relationship between mass and time. So we'll press OK, and as a consequence of that, each of these spectra have now been calibrated within CASA XPS. So when we convert these from time to mass intervals, and I'll give it a range of 300 for the delta mass factor, that'll increase the number of mass channels in the new VAMAS blocks that will be created. I press OK, and And then once again, if I overlay, now we can see that the hydrogen lines up much better. And let me just close the element library and the other dialog window, and then we can step through and see how these peaks appear. So that was 15. That's 15 aligning. This is an aluminium peak. So we're calibrating based on hydrocarbons, and you can see that the aluminium peak has lined up very nicely, with the exception of one of the measurements which has a greater uncertainty in the mass. And this one is a silicon peak. And again, that mass calibration has aligned these peaks quite nicely, apart from where there's a clear problem with the data.